All right, so now we've got 3 points, and we want to know if this point lies on the plane. Well, to take my 3 points, I need to use them to make 2 direction vectors, and then use any one of the points to make the equation. So I'm going to first find my direction vector first I'll find AB, 3, 3, 2, AC. And in this case, it doesn't matter that I went from A to B and then also A to C. I could have also picked B to C. It doesn't matter. You do need to use all 3 vectors, all 3 points to create your 2 vectors, but it doesn't matter which ones, because any 2 directions I have in the plane, I can always add those up to find different resultants on the plane. But I'm going to use AC because it's nice and orderly. So that's going to be up 6, up 3, and I don't know, a third dimension of 0. So now the equation of my vector is going to be our initial point. I can pick any one of those points. I'm going to go with 2, 3, 4, just because. And then a scalar of one direction and a scalar of the other direction. So now I want to know if this point 570 is on my line. So is there an S and a T value that would give us those 3 points is what I'm asking myself. So 2, 3S, 6T, 3, 3S, 3T, and 4 plus 2S. So this one is the one I'm going to use to tell me my S. Looking at this equation, S would have to be -2. So therefore, S is -2. If S is -2 coming up into this equation, I would have that 7 equals 3 minus 6 plus 3t. 3 minus 6, -3, add that over. T would have to be 10/3. So now I'm going to plug in my 10/3 and my -2 to see if it gives me 5. So let's test that out. You know, sometimes I give myself space, sometimes I don't. So 2 plus 3 times 10/3 is, 3 times -2 is -6. 6 times 10/3 is 20. And putting those together, 22 minus 6 does not equal 5. So my point does not lie on the plane.